Pythagoras. We need to make sure we understand Pythagoras. Pythagoras is the relationship between three areas, square areas, off a right triangle. So if I have this big area, this smaller area, these two areas add up to that one. That means that to get the middle area, I need to subtract. So I do 121 minus 36. I'm going to end up with 85 squares in here. 85 centimeters squared. And that does not talk about the lengths, that just talks about the three areas. Here we're talking about length. Okay? So if I want to work out the lengths, I can't add these lengths at all. That doesn't work. This length and this length do not add up to that length. However, this square area, 121 centimeters squared, and this square area, 104 centimeters squares, these squares add up to the big square, which ends up being 265 centimeter squares. Okay? I can then work out the unknown side length. I have an area to get the side length I square root. Okay? If I do that on my calculator, I get 265 square root. And the decimal value for that is 16.28. Okay, so that's approximately 16.28 centimeters. This is a better solution because that's an exact value solution. For here, again, we're going to use Pythagoras. So we're going to use this 9 square, or 81 squares. We're going to use this 8 square, which is 64 squares. And we're going to get this big square by adding those together, and I get 145 squares in here. So to go from the side area to side length, I square root. So the length of that side is the square root 145. Again, if we want a decimal value, I prefer the exact value, but the decimal value works out to be 12.04. Okay, so this length is approximately equal to 12.04. This one here looks like there is a typo here, but let's change this to 3.2 and 4.0. Okay, otherwise it looks kind of weird. So I'm going to take, if I want to find this length, I'm going to find this square area. So I'm going to do 4.0 squared, and I'm going to take away 3.2 squared, and that's going to give me the x squared. So doing that on my calculator, 4.2 squared minus 3.2 squared gives me 5.76. Okay, so x squared equals 5.76. Okay, so that's how big this square is. So if I were to draw a square here, there's 5.76 units squared in there. But I want the side length. Okay, so this is, just zoom in a bit, 5.76 units squared. Okay, that would be that square in here. And the side length is, if I square root that value, and I get 2.4 as my side length. Okay, in fact, this happens to be exactly 2.4. Okay, so here we need to make sure we understand how to draw nets and how to find surface areas. If I were to draw the net of a cube, okay, there's many nets I can draw. I'm just going to draw the cross type one. The main thing is I need to have all 6 sides. And then if each side is 36, this is a 6 square. So 6 by 6 square. The surface area